Um, so to start this afternoon, we'll focus on future of Lustre and its future features. And the first speaker is Andreas Dilger, who is the CTO of and principal Lustre architect at OneCloud. He has been working on Lustre for since its very first days, 20 years ago. His first commit in Lustre dates back from 1st December 1999. Mix between other commits from Peter Bram. So he's,
thank you. So today I'm talking about various features in the upcoming Lustre releases, and I'll try and focus on ones that don't have any other presentations at the conference today or tomorrow. As you can see, there's quite a number of new things going in. This is just the list of, sort of more major features that are, have specific developers working on them. There's, of course, a number of, smaller features that I'll also be pointing out that are going into the new releases. And, even though we have plans going out to 2.15. There's already, early discussions on newer features, but I tried to focus on things that are actually having people developing and working on them. So the first one, this was underway for more than a year, is persistent client cache. And this feature is quite interesting. It allows you to leverage storage that's local to the compute node or the Lustre client, and it does it in a way that is transparent to the file system namespace, so that users, applications don't have to operate in a second directory. They don't have to put all of their files in one specific location, or it's not a copy of the file system. And the interesting part of this is that it's integrated with how Lustre handles HSM. And rather than using HSM to stage data out to an external tape archive, instead it's actually using HSM to stage data into the local NVMe device on the client. And while it's in the NVMe device, it's released from the Lustre namespace, so the NVMe device has the local copy, and then the application running on the compute node can make any kind of changes that it wants. And it's stored inside a file system on the local device, right, ext4 or something like that. And so all of the local file system semantics apply. And once the file is opened by Lustre, it hands off all of the operations to the local storage. And so this is quite attractive in terms of reducing, latency. You get basically, exactly local file system performance. The one caveat being that new files that are created in the file system still talk to the MDS to create the file, but it's immediately created as a stub and it's stored in the local PCC, archive file system. And in order to maintain the transparent access semantics, the file is, if it gets accessed by other clients, it activates the HSM agent running on the compute node, and then it pulls it back into the main Lustre file system, like on an OST, and then other clients can access it. So it's only client local while one client is accessing it, but if you start having a shared access model, then it pulls it into the file system and it can be accessed in a shared mode. And one of the things that isn't in the 2.14 release is the shared read mode, so that you can actually have multiple copies on multiple nodes at the same time. And so you have some giant video file full of cats that you want your AI to work on. You can have one copy on each compute node. And the other thing that we haven't really tested is using the DAX, access model for persistent memory. But in theory, it should work transparently, because if you have NVRAM on your client and we're running with an ext4 PCC, cache file system, then all of the I/O access should be totally the same as the local disk file system, and that should give us very good performance for small I/Os. D&E is something that's been around for a while, but it's one of the issues that we found with it is that the functionality was there, but it was hard for people to use it. Because you don't know in advance if you have, you need a Stripe directory or not, and balancing space usage across MDTs is a bit of a challenge, and so we started making D&E easier to use. In 2.12, you could use LFS make dir -I to say, create this new directory on one of the MDTs, I don't care which one, it will try and find the one with the least space usage, right? And so that simplifies it a little bit, but you still have to know about LFS make dir or LFS set dir stripe to do that. And in 2.13, now you can set up the striping on the parent directory to say, instead of using a name-based hash for your file name to decide where new directories and files are being created, you can set this space hash, essentially, that says find the MDT with the least usage, and then create a remote directory there. And so the good thing about this is that it uses the normal make dir system call, and so that makes it easier if you set the space hash on the top, the root directory, maybe the top directory of user, each user directory, and then their subdirectories will be balanced to some extent across all the MDTs. And the good thing about this is that you can set the space hash, on your root directory, whether you have one MDT or 10 or whatever, and as soon as new MDTs get added to the file system, it would immediately start distributing some load onto those new MDTs, right, once the top level directories. It's not totally perfect, but it's definitely a step in the right direction. 2.14, we're going to continue this with a new feature. It's essentially automatic directory restriping. I mean, in 2.12, we already added the ability to manually restripe directories. And in 2.14, we're going to extend this so that once the directory gets beyond a certain size, it will start restriping it. And so then you don't have to make a decision at the time that the directory is first created whether it should be striped across MDTs. And the goal, of course, is to better manage space and performance across multiple MDTs in the same way that we do with OSTs, right? I mean, yes, it's possible to get unbalanced OSTs, but it's typically not a huge problem versus with D&E. I saw some numbers from Lawrence Livermore. They had some MDTs that were, 15% full and some that were 85% full out of their, 16 MDTs. And that's because there's like a top level static segregation between, each user directory. And if you have a heavy user, they might fill up their MDT quite quickly. And so, being able to manage the space and, increase your performance automatically is something that's quite interesting to a lot of people. Data on MDT, that was new in Lustre 2.11, I believe. And so there's been quite a bit of benchmarking. It's showing quite good performance improvements for small files. And so a lot of work was done, polishing a bit of the edges, improving performance. And one of the improvements that was included in 2.13 is the ability to migrate to and from data on MDT files. In 2.12, it was possible to, I believe, remove a data on MDT component, but you couldn't, you couldn't migrate a file into data on MDT. So if you had small files, it's not super hard, but if you had small files, you just have to essentially do data copies and then rename the file on top of the old one. With 2.13, now we've integrated data on MDT with the file level redundancy to mirror a DOM component, and so we can use that at the same time to add or remove a DOM component on an existing file. And there was a number of improvements done. You saw the presentations earlier to try and improve MD test for IO 500. And so that in terms of keeping locks local to the clients and keeping them after file create. And so moving along this direction, we're going to continue working on some performance improvements. Also usability in terms of balancing data on MDT component size based on the file system free space. Because right now, people are, as they're deploying it in production, they're finding that, how much space do I need to, allocate to my data on MDT? Do I overestimate or underestimate? It's kind of hard with, especially with LDiskFS. With ZFS, it's less of a problem because ZFS has dynamic inode allocation. But with LDiskFS, you have to, balance it. And so we're going to make that a bit easier. Some performance improvements, merging the writes with the close so that you reduce RPC count. And something that was asked by a few people, being able to have an MDT only file system. If you only have very small files, maybe you don't need OSTs. And actually that functionality can potentially be used to migrate an existing ext4 or ZFS file system to just take the existing file system, turn it into MDT0, and then start adding in OSTs and MDTs to increase the capacity, right? And that's not something that's going to happen in 2.14, but that's the first step along that way. LNet has had some improvements. Multi-rail routing was the main feature that was added in 2.13. And we've had multi-rail improvements over the last few releases. And so 2.14 will continue as well. The user-defined selection policy is something that's important for, did I miss? No, where am I going here? There we go, sorry. Multi-rail selection policy, it's for big NUMA machines, so you can select interfaces that are close to your client process based on NUMA nodes, or if you have a multi-rail across an Ethernet and an InfiniBand interface, and the InfiniBand is not as fast, you may want to prefer all traffic to go over InfiniBand. Right now, it will sort of try to round robin them and send 10 messages down the InfiniBand and 1 message down the Ethernet, but now you can specify, preferences. So already a bunch of this has been covered in the IO 500. We did quite a bit of optimization on the client side. MD metadata performance for DNE, read ahead, overstriping, which is essentially just, the functionality has been in Lustre, for years that you could do this. Normally we thought it would be an accident and we prevented people from doing it. But as the OSTs are getting huge and, have very high bandwidth, overstriping actually, is beneficial for clients to be able to leverage more performance from a given OST. Small file improvements, strided read and write, has gotten into 213, but there's still more work in those areas. I mean, some people might consider, are you gaming the benchmark for IO 500? But in fact, IO 500, the whole goal of it is that if you improve performance, let's say in the IOR hard, I think you're improving performance for actual applications, right? So I don't consider this to be, you're optimizing for the benchmark. I consider this as, if you're doing great at, 4,800 and, 48,007 byte writes interleaved from thousands of clients, I think you're also optimizing, crazy applications, right? And those numbers were not just picked out of thin air. There's actually applications at Sandia labs and things like that that are doing, these kind of bad I/O patterns. Another functionality that we've done for improving I/O is the local client mount, and that's interesting because with a lot of the newer features such as mirroring and HSM and things like that, it's actually beneficial to have clients mounted on the OST. And so one of the problems that's prevented us from doing that in the past is that if the OSS or the MDS crashes, then you had this client that's never coming back, and it means your recovery would wait for the entire duration of the timeout before the recovery finishes, and this client is never coming back. And so there's now a patch that will automatically detect when the client is mounted locally, and it will exclude it from recovery, and so that if the MDS reboots, it'll come back, it's not going to wait for that client. And so this is kind of the first step in optimizing the I/O patterns. You can do, instead of sending an RPC to your own node, it could just do a function call, right? And so that's, again, something that's not in 214, but it's the first step in allowing clients and servers to run. And it works most of the time today, so it's not like it's a huge problem, but I think we can do better than what we have. Again, this slide, performance improvements from Flash. There's quite a bit of this was already presented, and I guess one of the interesting ones that in the middle here, self-extending layouts, Cray was working on this. It's actually essentially a form of progressive file layout where the components in the middle of the file can be dynamically sized. And so if you have, let's say, a flash tier and a disk tier, and you want to put some amount of each file, the first 128 megabytes or something like that on flash, but suddenly your flash tier is full, you don't want people to get, out of space errors in the middle of their application run. And so with self-extending layouts, it can detect that, these OSTs are full, I'm not going to continue allocating to those OSTs, I'm going to transfer over to the disk-based OSTs, immediately and continue writing. And so it avoids, out of space in the middle of a file, and handles the common case where the flash storage has a much smaller capacity than the disk storage. LDiskFS, still an ongoing development area, and I think Peter mentioned this, that a number of the features that were Lustre specific have been merged into the upstream. The large X adders, was in upstream for quite a long time, but we didn't have the ability for the 64K. This large X adders wasn't handled as well upstream. Large directories was just recently added, and same with the project quota was just recently added to the upstream E2FS progs. And there's one more feature, Dear Data. It had started work towards being merged upstream, but got stalled out because it needs some extra unit testing. So that needs to be finished off. There are some other features in ext4 that we haven't started using in Lustre yet, big alloc. It makes the block allocation, supposed to make the block allocation more efficient. So far, our testing hasn't shown, a lot of real-world improvement, but we're also, trying to see what we can leverage from that feature. On the flip side, for very small files stored in the file system, there's a feature called inline data that, could allow you to efficiently store file data directly inside the inode on the MDT. So if your workload had, 50-byte files or 300-byte files, you could actually get a space efficiency, some potential performance improvements. We haven't been able to test that out yet, but it looks promising. That it just hasn't been an issue for most Lustre users because they typically assume to be large files. But once you start getting into genomics and things like that, they might create 1 million very small files in one directory, and so we'll see how that pans out. The metadata checksums, as in the upstream ext4, and I think we could start using it. There were a few bugs that we fixed recently, and there's actually a few other newer features that haven't even landed into upstream ext4 yet. The Verity, which is data checksums, but the problem is it's only for read-only files. So you'd write the file, you would do a after the fact data checksum, and as long as the file doesn't get modified again, your checksum would be persistent. Directory shrink is actually something that's interesting for large OSTs. We'll see, actually, there's another feature just in early development as well that's not listed here, I should have mentioned, is a parallel fscheck for ext4, which is quite useful as OST sizes get huge. We're into the, in the field, they're deploying OSTs that are, hundreds of terabytes, 500 terabytes, pushing sometimes, we have test file system that's almost a petabyte, right? And so, that used to be the whole file system, and now it's one OST, right? So it's pretty interesting that ext4 has, scaled for such a long time. File level redundancy. I think this is one of the, most interesting areas of Lustre development today. In terms of, once we've had progressive file layouts and the composite layouts, I think that there's so much that we can do with that it's really becoming an interesting area. And so there's a number of features going into 2.13. Like I said, mounting the OST directly on the OSS, mounting the file system directly on the OSS without breaking the recovery. There's a tiny feature added to allow specifying pools so that if you say I have a flash pool, I have a disk pool, and the file is mirrored onto the two places, if your flash pool is getting full, you can delete it by naming just the pool rather than having to parse out the output and find out which component number is the flash pool. So that's a bit of ease of use. We're deep into the development of erasure coding, and so it's turned out to be a little bit more complex than we had hoped, but it's pretty much on target, I think, for 2.14. We're hoping we might have been able to get it into 2.13, but it's quite more complex. And so this will be interesting. It allows you to add erasure coding to existing striped files, so even files that were created before Lustre 2.14 is out. Any striped file will be able to add in an erasure coding component so that you can add redundancy after the fact. And HSM, right now we have sort of separate layouts for PFL and FLR. Ooh. And didn't break. So what we'd like to do is integrate the HSM component as part of mirrored files so that you can do things partial archive and restore for files onto tape or S3 archives, and you can have multiple archives in a single file. I think it's going to provide us again, combinatorial improvement in functionality, right? So you can do all kinds of complex layouts rather than just the current situation where you have one archive per file. And what that will allow, going forward, being able to do file versioning with reflink potentially inside the namespace, and then you could have access to different versions of your file through namespace operators. We already do have, I think in 2.13 and maybe even in 2.12, you have the ability to open a read or write descriptor into a specific component, but you'd have to know a lot about what you're doing in order to be able to read or write an old version of your file, and being able to add that into the namespace, so you can say, open the 4th oldest version of the file name, or say, open the version of the file name that's, 2 weeks old, right? And I think that would be super interesting and useful. And once the infrastructure is in place, I think having the namespace integration is okay. I have 1 minute left. Various other smaller features, foreign layouts. It's something from Intel to integrate with their DAOS, stacked file system. Overstriping is mentioned. StatFS optimizations. Lazy size on MDT was something went into 2.12. Hooking it into LFS find makes it more efficient. Peter mentioned lots of upstream kernels features, a bunch of new, small little interface improvements for various workloads, fallocate, statx. Those are, while they don't get, a whole feature listing on themselves, I think these are all improvements for, helping users use Lustre better. Another big feature, I think, from Cray, pool quotas for OSTs, is helping us to manage Flash a lot better than what we have today. And of course, once we have OST quotas for pools, it'd be nice to have MDT quotas for pools. We'll see when that comes around. What else? Sebastian's working on client-side data encryption, and so even though we have Kerberos and shared secret key encryption for the network protocol, that the data is decrypted and written to disk, on the server side. And so what we're working on here is data encryption, end to end. And so the clients encrypt the data, it gets sent over the network, it's stored encrypted, and only the clients can decrypt it, right? And so the OSTs never actually need the data keys. The good news about this is, we're smart enough to know that we're not smart enough to develop our own encryption. So it's using the fscrypt library that ext4 and f2fs are using in the kernel, and so that's being used by Android and lots of devices today. And so we're going to be using the same interfaces and the same code to handle the data encryption and file name encryption. And I think it'll be important for Lustre use in a variety of different, medical fields and things like that. And this is the last slide of features that are actively under development. Metadata write-back cache. Oleg had developed some prototypes in this area, and we got very good improvements, 10 to 20 times for single client, untarring a kernel tarball and things like that. And so it's quite significant, and Lustre's had infrastructure to do this for a number of years. Just nobody was able to work on, implementing it. And so for 2.15, we're hoping to get an actual version of this implemented that has, proper space management and things like that. And I think that's the last. I can stop there. Questions?
Question about persistent client cache.
Yeah.
Is it going to be a component, so only part of the file can be on client?
Right now, you have to, the way it's implemented, you have to move the whole file into the client cache, and then it's, if you're doing a read-write version, then it's released from Lustre, and so it only will exist in the client cache. And so the feature that I was talking about for HSM, where you'd have the HSM component be part of the Lustre layout rather than a separate XAdder, that will allow us to do things like partially store, the file in the PCC, and you could still have a copy of the file in the disk at the same time, right? And it would know that the PCC copy was the valid one, but you'd keep the other parts of the file would be marked stale or something like that, right? So that's what you would get once we do the layout changes.
Thank you.
A related question. So this mechanism relies on the HSM coordinator?
Yeah.
Okay. And what happens if another node needs to access the file? It will trigger an HSM restore?
Yeah.
So what prevents the client from doing the I/O on the cached file?
Well, it would trigger the restore, but the restore is blocked until the client releases its open handle, right? And so, it's sort of true with tape archives, right? You don't expect instantaneous response if the file is restored, if the file is released and you trigger the restore, your tape library might depend on an operator to load it, right? And so the clients on the other nodes are blocked, indefinitely until the file is released from PCC.
Other questions?
Okay.
Thank you, Andreas.
Thank you.